Okay, so what is my P?
64.
What is my Q?
1.
Okay, so let's start with the factors of P. And remember, factors always come in pairs, so plus or minus 1, positive or negative 1. And what goes with 1? Positive or negative 64. Does 2 go into 64? Positive or negative 2 and positive or negative 32. Does 3 go into it? Nope. Does 4 go into it?
Yes.
You can always tell if 3 goes into it. Add the 2 digits. If it's not a multiple of 3, 3 doesn't go into it. 6 plus 4 is 10. That's not a multiple of 3, so 3 does not go into it. Does 4 go into 64? How many times?
16.
5 does not go into it because it doesn't end to a 5. 6 doesn't go into it because 2 and 3 don't go into it. 7 doesn't go into it. Does 8 go into it?
Yes.
And I only need to write one 8. I mean, you could write both 8s, but it will end up just being... And then Q is positive or minus 1. So the next thing that we have is our possible rational roots. So I'm not saying these are rational roots. These are possible rational roots. So any of these numbers could be our roots. And we're going to put them in order from least to greatest. So positive or negative 1, positive or negative 2, bless you, positive or negative 4, positive or negative 8, positive or negative 16, positive or negative 32, positive or negative 64. So those are our only possible rational roots. If none of those happen, then we have no rational roots. So we're going to test 1. We have 1, negative 8, 20, negative 32, and 64. So let's go ahead and test it. One times 1 is 1. We get negative 7. 1 times negative 7 is negative 7. 20 plus negative 7 is 13. 1 times 13 is 13. Negative 32 plus 13 is negative 19. 1 times negative 19 is negative 19. 64 plus negative 19 is positive 55. Is 1 a root? Why not? The remainder is not a 0, so this is not a root. So now we're going to go over to negative 1. And we're going to keep testing until we get a remainder of 0. Okay, so far we've tested 1, we got a remainder. We tested negative 1, we got a remainder. We tested 2, we got a remainder. We tested negative 2, we got a remainder. So now we're going to test positive 4. You can't give up. Okay, 4 times 1 is negative 8 plus 4. 4 times negative 4. 20 plus negative 16. 4 times 4. Negative 16. 4 times negative 16 is negative 64. So, what did we just prove? 4 is a rational root. Okay, so now we end up with x to the third minus 4x squared plus 4x minus 16. Oh man, that is not an x squared.
It's an x cubed.
It's an x to the third. So I want you to know that they're not always are going to be able to be factored. So what we're going to do is we're going to test 4 again, and we're going to use it here. So now I'm going to test 4 because it might be a double root. Can you stop packing up, please? So I'm just taking this and bringing it down. and I'm going to test 4. Okay, so 4 times 1 is 4. Negative 4 plus 4 is 0. 4 times 0 is 0. 4 plus 0 is 4. 4 times 4 is positive 16, and we're left with a remainder of 0. So that means that we have a double root of 4, and then we're left with x squared plus 4. Well, x squared plus 4 is not factorable, it's prime, so that means our only rational root is a double root, and that is 4. So again, we tested 1, we tested 1, we tested negative 1, we tested 2, we tested negative 2. None of those worked. Number 4, we were left with a remainder of 0, but we don't know if this is factorable, so we're going to test 4 again. Miss Fleury, why did you test 4 again? Because we might have a double root, so we're going to test it again. And when I did, I got another remainder of 0, which means I have a double root of 4. What was left over? What was left over was prime. We can't factor it, so we have no more rational roots. All we have is 4.